Those people that were here yesterday, you guys are going to lead us through here quite nicely. Now, if you have your note open from yesterday, please don't, because you'll have to commit this to memory anyway. So if you're copying from yesterday, try not to. Can somebody tell me, I'm going to start with the 45, 45, 90 triangle. Okay, can someone please tell me how I can get a 45-degree angle from? Someone go ahead. Good. So we're going to do this, we're going to start with a square. Of length 1. And then we're going to chop it diagonally. So what I'm going to do is, here's my beautiful square. It has to be a square because squares have 90-degree angles. Secondly, when you cut them diagonally, like this, it's going to bisect the angle perfectly like that. All right, somewhere here then. Once I chop that in half, what am I left with? Yeah, Chris, go ahead. Good. So we're going to end up with a triangle that is 45 degrees, 45 and 90. The side lengths, I said, were all 1. So it's going to make that side 1 and that side 1. Okay. Now, could someone of those two girls tell me, please, how I solved the hypotenuse, please, other than using your calculator? Grace, go ahead. Good. Yeah, go ahead. Yeah.
C squared equals A squared plus B squared.
Good.
C squared equals Y squared plus 1 squared. And X squared equals 2.
Yeah.
So X is 2.
Okay, so go to the next slide and finish up. What that means, that is for any triangle that has a 45-degree angle, the proportions of the sides are 1, 1, and root 2. So if you say in your life, and we're going to talk about sine, cosine, tan of that right now, if you say in your life, sine 45 is 0.707, you will lose half a mark. I'm going to work here a little late here, sorry, Tristan. Okay, so where that comes from, there's your opposite, there's your adjacent, there's your hypotenuse. Okay, lovely. Can I get a third person? Brad, is that a hand? That's tan 45. Good. So do what? This is awesome. Okay. And that sort of makes sense. All that tells you, if it's a 45-degree angle, you're going the same distance across as you are up and down, which makes sense, right? A 45-degree angle would be a perfect balance for that. Okay, now we apply this a lot, and we did a whole bunch of horribly complicated examples last night, but I want to do the next triangle after this. That's the first one, 45, 45, 90. So the logic behind it, we'll use lots in this course. Start with a square, chop it diagonally. Okay, that's what happens when you get a 45-degree angle. Were you here interesting yesterday? I can't remember.
I'll get the video later.
Tisk, tisk, tisk. That's true. All right, our next triangle is a 30, 60, 90 triangle. Can someone please tell me in English how we prove this one? Yeah, Julie, go ahead. So we're going to start with an equilateral triangle. Now, Julia, can you please tell the class, if you remember, why we chose an equilateral triangle to begin with? Remember? Okay, yes, but not really, okay. What are all the angles for an equilateral triangle? Yeah? 60, 60, 60. So when you chop a 60-degree angle in half, it's going to be 30, which is what we need. Okay, I'm going to write down of length 2. And chop it in half. Right, that's such a mathematical term, chop in half. So, I'm going to draw my beautiful triangle. Looks something like this. Equilateral, if you remember, has all sides and all angles the same. The reason I want to make it 2 is because when I chop it in half, what's the side length going to be then? Yeah, 1, which would be a lot nicer, okay? So I'm going to divide this by 2 and then I'm going to Okay, I don't, that's a true fact, I really don't. Okay, so what I'm gonna do for this is chop it in half like this, pop. Okay, and that leaves me with a triangle that looks something like this. And hopefully for those that were here yesterday, this is all coming back. Okay, can someone explain to me why the top angle is now 30? Okay, Scott? Half of 60. Can someone explain to me why the bottom left triangle is 90? The bottom left angle is 90. Okay, go ahead, Owen. Perfect 90 angle. Okay, so now I've gotten my 30, 60, 90 triangle. Can somebody tell me what the other two sides will be? Let's start with the bottom side. What will the bottom side be? Luke? 1. Good. I'm going to call this X because I like math. All right? It is. Yeah, okay. What is it? Square root of 3. But I'm going to do it for those for the one here. So 2 squared equals x squared plus 1 squared. 4 equals x squared plus 1. 3 equals x squared. X equals 3. Okay, now we want to use exact values here. That's what we're getting into, okay? I was telling the class this yesterday for those that were here. You're with me here still? Okay, but I had actually your brother came inconveniently into my class on Friday. Oh, don't roll your eyes at him. He's a kind human being, I'm sure. So anyway, he told me, I asked him, I said, because I'm always stressed out, I want to be doing a good job. So I said to him, I said, so what's like the biggest thing you think I should change for my course so that you guys can do better in First Universe? And he said, more trade, more trade, more trade. He didn't get a calculator. I don't know if you talked to him at all, but he didn't get a calculator in his first year math courses. So stuff like this, little shortcuts to be able to calculate angles in your head is very, very helpful for him in university. Okay? And anyone here that's planning to go into science, he went into engineering, right? So, or anything like that is technical of a similar situation. So let's go to this here right now. I'm going to draw my triangle here. There's 30, there's 60, there's 2, there's 1, there's root 3. All right. Now I'd like anyone in the class here to be brave and let me know what sine 30 is without using their calculator. Skylar, go. 1 over 2, how'd you get that? So if this is your key angle for 30, the opposite side is 1 and your hypotenuse is 2. Thank you. Can I get someone else to tell me what cos of 30 is, please? Yes, someone go? Root 3 over 2. For the same reason. If there's your 30-degree angle, that's Jason over hypotenuse, so root 3 over 2.
So Jason is the bottom one?
No, because if this is your... Okay. Too excited here. If this, right, but if this is your primary angle, right, it's opposite adjacent. Okay, what's tan 30 going to be? Someone else? So I'm just letting you someone else. I'm telling both you guys, you know what your hand raisers. No one else knows what tan 30 is? Goodness gracious me. Tristan, go.
Root 3 over 1?
Close. 1 over root 3.
Right.
Right, because again, if this is your angle, right, opposite over facing 1 over root 3. Okay. All right, on the next board, I'm going to say sine of 60. So you get lots of good numbers here. I get 3 new people to be brave and try to measure it. Go ahead. Square 3 over 2. Now again, because this is your 60, your opposite angle is root 3. Can I get another person to tell me that? Yeah, go ahead. 1 over 2, awesome. And finally, is tan of 60? Brad? Tan of 60? Root 3 over 1, awesome. Or just root 3, right? Now again, these proofs aren't horribly complicated. The thing you have to remember is what I printed in blue on both cases. For the 45, 45, 90, take a right angle, take a square, chop it in half. For the 30, 60, 90, take our equilateral triangle, chop it in half. And I'm going to, Summer, do you mind if I embarrass you and tell the class what you told me at lunch yesterday? Okay, so what she says, this isn't super difficult, but it stretches your brain in a different way. Is it something like that, right? Is that basically that? So this stuff you should practice. It's not something that's natural. Like you have to think about it when you're doing this stuff. It's not like you can sort of walk into this and do it. So this isn't, you can't luck into this unit. I think that's why it's difficult for people. You got to actually study to do well in this unit. So is that mean to say? I don't know if it's mean to say, but it's the truth. Okay, so that's what you said. It stretches your brain in a different way, something like that. I think was the quote. Now that you're totally embarrassed, I'm going to hit pause in the video, and then we're going to start with today's lesson. Was there anything from last night?